Welcome to this video. Today, we're going to talk about daily habits that reveal a low IQ based on psychology. When psychologists study intelligence, they don't just look at test scores, they look at daily patterns, how people sleep, how they focus, how they plan, and how they respond to information. Because across decades of research, certain everyday habits consistently track with lower cognitive performance, weaker executive control, and reduced learning efficiency. They look at the whole picture, and some of them are far more common than most people realize. Let me know in the comments if you know someone who does these things. The idea of IQ is often misunderstood. IQ tests were originally developed in the early 20th century to measure specific cognitive abilities, including reasoning, working memory, processing speed, and problem solving. Modern intelligence research does not treat IQ as a measure of a person's value. It treats it as a statistical description of how efficiently certain mental systems are working. You can also see someone has a low IQ by their habits. At the same time, psychology is very clear about something important. IQ is not destiny, and habits are not identity, but habits are measurable. And when researchers observe large groups of people over time, they consistently find that some daily behavioral patterns are associated with lower performance on cognitive tests, weaker academic outcomes, poorer decision-making, and reduced learning efficiency. Not because those habits make someone unintelligent, but because they directly affect the brain systems that intelligence tests measure. Everything in this video is based on established findings from cognitive psychology, neuroscience, and educational research. These are correlations and mechanisms, not labels and not permanent traits. One of the strongest and most consistently replicated findings in cognitive science is the relationship between sleep and cognitive performance. Sleep is not passive. During deep sleep and REM sleep, the brain actively consolidates memories, regulates emotion, clears metabolic waste, and recalibrates synaptic connections. Large bodies of research show that chronic sleep restriction impairs working memory, attention control, processing speed, executive functioning, and reasoning ability. Laboratory studies repeatedly demonstrate that even moderate sleep deprivation produces declines in performance comparable to significant drops on standardized cognitive tests. Neuroimaging studies show that sleep loss reduces activity in the prefrontal cortex, the region most involved in planning, impulse control, abstract reasoning, and complex problem solving. Long-term sleep deprivation has also been associated with poorer learning efficiency, lower academic achievement, reduced emotional regulation, and higher rates of cognitive error. Not sleeping enough does not change someone's inherent potential, but it reliably lowers how efficiently their brain performs the functions that intelligence tests are designed to measure. Another habit that has been studied extensively is chronic multitasking, especially digital multitasking. Psychologists refer to this as media multitasking, rapidly switching between phones, apps, notifications, videos, messages, and tasks. Research from cognitive psychology and neuroscience shows that heavy multitaskers tend to perform worse on measures of sustained attention, working memory capacity, and filtering of irrelevant information. Experimental studies repeatedly find that frequent media multitasking is associated with poorer selective attention, weaker cognitive control, and reduced task switching efficiency. The reason is not mysterious. The human brain cannot truly perform multiple complex cognitive tasks at once. It switches rapidly between them, and each switch carries a measurable cognitive cost. Over time, habits of constant switching train the brain toward shallow processing, reduced persistence, higher distractibility, and weaker error monitoring. All of these patterns are consistently associated with lower performance on intelligence-related tasks. This does not mean technology reduces intelligence. It means that a daily habit of fragmented attention weakens the systems that support reasoning, memory, and complex learning. Sustained focus is one of the foundations of high-level cognition, and habits that repeatedly fracture it produce measurable cognitive consequences. Another well-documented pattern is the habitual avoidance of mentally demanding activities. Cognitive and educational psychology consistently show that people who regularly engage in effortful thinking maintain stronger reasoning ability, learning efficiency, and memory performance across the lifespan. Cognitively demanding activities include sustained problem solving, long-form reading, structured learning, strategic planning, and complex skill acquisition. These activities strongly stimulate executive function networks, working memory systems, and attentional control circuits. In contrast, chronic avoidance of mental effort is associated with weaker academic outcomes, slower reasoning development, poorer long-term retention, and reduced adaptive problem solving. Neuroscience adds an important layer. The brain is plastic. Circuits that are frequently activated strengthen. Circuits that are rarely activated weaken. When daily routines rarely require sustained thinking, the neural systems that support complex cognition receive less stimulation. Over time, this shows up behaviorally as lower tolerance for complexity, faster mental fatigue, and reduced persistence, all of which are linked to lower measured cognitive efficiency. Another factor repeatedly identified in research is the quality of daily cognitive input. Reading and language exposure play a major role in cognitive development throughout life. Reading exercises vocabulary growth, abstract representation, inference generation, long-range attention, and memory integration. Large-scale longitudinal studies show that individuals who read regularly, especially challenging and varied material, demonstrate stronger verbal intelligence, broader general knowledge, and higher analytical reasoning ability. In contrast, daily routines dominated almost entirely by passive, low cognitive demand content are associated with weaker vocabulary growth, lower knowledge accumulation, and reduced abstract reasoning development. This does not mean entertainment is harmful, but cognitive development depends partly on input quality. What the brain processes each day becomes the material it learns to work with. Over time, habits of shallow cognitive input correlate with lower performance on measures of reasoning and comprehension. Another well-established domain is self-regulation. Self-regulation includes impulse inhibition, emotional control, delay of gratification, and goal maintenance. These abilities are primarily coordinated by the prefrontal cortex, the same region heavily involved in intelligence test performance. Research on executive function consistently shows strong associations between impulse regulation and academic success, problem-solving ability, long-term planning, and learning efficiency. Individuals who struggle chronically with impulse control tend to show weaker performance on tasks measuring working memory, attentional stability, and cognitive flexibility. This matters because intelligence is not only about solving problems, it is about holding goals in mind, resisting distraction, and managing interference. Daily habits that reinforce immediate reaction, constant stimulation, and avoidance of discomfort weaken these regulatory systems over time. Another habit pattern linked to cognitive efficiency is daily organization and planning. Planning is a core executive function. It involves sequencing, forecasting, resource management, monitoring progress, and correcting errors. Neuropsychological research directly links planning ability to fluid intelligence and adaptive reasoning. People who maintain structured routines that involve prioritization, scheduling, and long-term goal tracking tend to perform better on problem-solving and reasoning tasks. In contrast, chronically disorganized daily behavior is associated with poorer working memory use, reduced task persistence, lower cognitive flexibility, and higher error rates. This is not about personality, it is about how often the brain practices anticipatory control. When daily life rarely requires planning, the neural systems that support it receive less stimulation. Over time, this can weaken strategic reasoning and adaptive problem-solving efficiency. Another important factor is metacognition, the ability to think about one's own thinking. Metacognition includes recognizing errors, evaluating evidence, adjusting strategies, and updating beliefs. Research consistently shows that people who engage in reflective thinking demonstrate higher learning efficiency, better reasoning transfer, and stronger problem-solving adaptability. Conversely, habitual resistance to feedback is associated with slower skill development, weaker error correction, and reduced conceptual change. These patterns matter because cognitive tests partly measure how efficiently a person updates mental models. Daily habits that avoid reflection or dismiss corrective information reduce opportunities to exercise these processes. Learning science also highlights the difference between active and passive information use. Passive exposure involves consuming information without questioning, organizing, integrating, or applying it. Active processing involves summarizing, comparing, explaining, testing, and generating examples. Decades of research show that active processing produces far stronger cognitive development than passive intake. When daily habits revolve around endless consumption without mental manipulation, working memory, reasoning, and long-term integration systems are underused. Over time, this is associated with weaker knowledge networks, lower transferability, and reduced analytical depth. Across all of these habits, a consistent theme appears. They all affect executive functions. Executive functions include attention regulation, working memory, inhibition, planning, and cognitive flexibility. These are the same systems most strongly associated with IQ performance, academic success, and adaptive reasoning. When daily habits repeatedly undermine these systems, cognitive efficiency declines, not as an identity, but as a functional outcome. And the opposite is also true. When daily habits strengthen these systems, cognitive performance improves at any age. So what does psychology actually show? It shows that intelligence is not only something you measure, it is something you express through daily mental behavior, sleep patterns, attention habits, cognitive engagement, self-regulation, information processing, reflection. None of these are trivial. They directly shape the brain systems that support reasoning, memory, learning, and decision-making. That is why psychologists do not divide people into smart and not smart. They study cognitive efficiency, because efficiency rises and falls with how the brain is used. The most important takeaway is this: habits linked to lower cognitive performance are not labels, they are signals. Signals about which mental systems are being overworked and which are being undertrained. And that makes them not judgments, but leverage points. Because what daily habits can weaken, daily habits can also strengthen. And in cognitive science, that principle is one of the most consistently supported findings we have. Thanks for watching, and don't forget to like and subscribe.